Right, so I've overcome my technological challenges, and I am not really going to delve into my first slide because I don't think the challenges of reproducibility need much introduction to this audience. And so I'm going to move directly to this slide, and we've now seen this. This is the third time you've seen this at this conference. So this was a reproducibility survey that Nature carried out last year, and the intention was to delve deeper into the attitudes of researchers to reproducibility challenges. So we surveyed 1,500 scientists across the life, physical, and chemical sciences. And what we found was that 70% of researchers reported failing to reproduce another scientist's experiment, and more than 50% failed to reproduce their own experiment. There was disciplinary variation in the level of confidence that perspective engendered in the published literature. Physicists and chemists were more confident in the published literature. The good news is that 1/3 of the respondents had taken active measures to improve reproducibility in their labs. In the past 5 years, very often that focused on independent replication within the labs and an attention to documentation of data and methodology. So the key culprits that this survey identified was selective reporting, pressure to publish, and low statistical power or poor analysis. So what can journals and publishers do to be part of the solution? Our own approach is focused around 4 pillars. Advocacy, we've been quite relentless in covering the issues and challenges around reproducibility. In Nature magazine, we've also developed resources for researchers that address certain pain points that we've discovered. Over the years, we've developed policies that enhance and support reproducible research, and I just want to briefly mention the Springer Nature Data Policy that we rolled out last year. The goal with that policy was to essentially develop a data policy that is coherent across the entire corpus of Springer Nature journals, which is more than 2,000 journals, and the ultimate aim is for every journal in the Springer Nature portfolio across a huge disciplinary breadth to have a data policy. And as of this spring, we now have 1,000 journals that have adopted a data policy. And then finally, we've focused on developing infrastructure to support our policy imperatives, and that's a range of different efforts, really, starting with creating platforms like Protocol Exchange to enable publishing of protocols linked to our papers, launching journals that are dedicated to data publishing. I also want to mention that Nature Human Behavior is the first Nature journal to launch a registered reports format in January 2017. And the goal with this format is to attempt to reduce publication bias. I also want to note that our sister division, BMC, has also launched a registered report format in BMC Biology, and BMC Psychology is also trialing results-free review. And then finally, shift the incentives. I think at many different sessions across this conference, we've heard the issue of a broken incentive structure being raised, and the fact that a broken incentive structure, an incentive structure that relies almost exclusively on publication of articles, feeds into all the other issues that we're seeing around challenges in reproducibility, challenges in research integrity. So I think really what I want to say here is that this is a deep problem, and I think we have to start addressing this problem hand in hand with addressing issues around reproducibility and research integrity. And it's not a problem that any single stakeholder can solve or attempt to move. So we all have a responsibility to engage and contribute productively to the discussions, and journals are a key part of that. So Daniele talked a little bit about what do we mean by reproducibility, and I just want to use the slide to illustrate that the community hasn't actually converged or settled on definitions of reproducibility or replication. We use them interchangeably, and we use them in quite imprecise ways. So this is just, these are just two definitions from the Goodman-Fenelli-Unides science translation paper and the ACB Data Reproducibility Task Force's white paper that I have found very useful and instructive. And I think the point I want to make is captured here in the statement from the Goodman-Fenelli-Unides paper, that none of these types of reproducibility can be assessed without a complete reporting of all relevant aspects of scientific design, conduct, measurements, data, and analysis. And so that has really been our approach, to focus on transparent reporting and to raise the bar on reporting standards. And our effort has concentrated on 4 key areas: methodology, data, code, and materials. And today I'll talk to you mostly about our efforts on methodology and data. So we embarked on our reproducibility efforts in May of 2013, and a signature feature of our reproducibility effort was the development of an 18-point checklist of reporting standards for life science papers. The checklist approach itself was very much inspired by what is accepted and settled practice in the clinical sciences. The checklist focused on key methodological and analytical parameters, including statistics, a statement of in-lab replication, which at the time we thought would be very controversial, but in fact it's been entirely painless to have authors report on in-lab replication, mandatory reporting on blinding randomization, sample size estimation. And these 3 parameters were actually identified and came out of recommendations, grew out of recommendations that were made at an NINDS workshop that Patricia referred to, and was summarized in this landmark white paper that called for transparent reporting to optimize the predictive value of preclinical research, from Landis et al. The other aspects of that initiative was really to raise standards and reporting of statistics, to introduce more scrutiny on statistics during peer review. We also took what at the time was a really important step, and now other journals have done this as well, to eliminate length restrictions on methods sections and to continuously encourage linked step-by-step protocols via protocol exchange. In the 4 years since we introduced these range of initiatives, some of our journals are now mandating protocols on specific kinds of papers. And we also encouraged provision of source data, or the data behind the graphs. And since we've rolled out that initiative, we've also now created avenues on our publishing platform to make the source data accessible to readers. So this is really what we are seeing. I can tell you at an anecdotal level that there is a striking increase in the standard of reporting across our papers. You know, you're consistently not only seeing definitions of sample size, but a lot more granular information about what the sample was. You're seeing statements of independent replication. A very large number of our papers now have source data, and increasingly you are really seeing a shift in terms of the approaches taken with regard to data representation, more transparent approaches to data representation that show you the full spectrum of the data. So Malcolm McLeod is carrying out an analysis to look at the impact of the checklist as an intervention and its impact on reporting of measures which might reduce the risk of bias. So he's looking at 220 papers across 9 Nature journals. The protocol was published in Scientometrics last year, and we are eagerly expecting data from Malcolm in the next few weeks and months, I think. So what do authors say about the checklist? Well, I'm going to give you some anecdotal feedback first. The checklist undoubtedly requires enormous time and effort. There's no question about that. But in general, the feedback we've had has been uniformly positive. I've put up a couple of quotes there. I love the checklist so much that I forwarded it to everyone in the lab to adhere to it for all manuscripts and keep an account. I'm not going to read that one. Author feedback in author surveys, more than 50% of authors report appreciating the value of the checklist for increasing the reproducibility of published research. The checklist was beneficial for presentation of the manuscript, and just under 50% felt that the effort taken to complete the checklist, the added value of the checklist outweighed the effort taken that was required to complete it. But what we don't yet understand, and what we are very keen to understand, is how has the checklist influenced research practice? So as I said here, certainly some people are distributing it throughout their labs. We've heard that anecdotal feedback. We've heard authors tell us they are integrating the parameters that are listed in the checklist into their design, experimental design. But we don't really have systematic feedback on how it's actually impacting upstream lab practices. And we're hoping to get insight into that later this year by doing an author survey. So it is indeed a long road to reproducibility. The reproducibility initiatives and policies we have in place do require time and effort from authors, but they absolutely require time and effort from journals and editors, and an incredible level of perseverance. So there are, again, disciplinary differences that track quite closely with the challenges that have been identified with reproducibility, but it can take anywhere from 1 to 3 hours per manuscript per editor for us to monitor compliance with the checklist. And what we've learned, and what has also been identified, I think, in a number of white papers and task force recommendations, is that statistics is a major pain point. Authors really struggle to provide the information relating to descriptive statistics in the checklist. We often find what are seemingly straightforward issues missing in the paper, missing definitions of sample size. There's confusion about sample size. There's a lack of clarity as to whether the data is actually a representative experiment, if it's aggregated from independent experiments, and so on. And I think this really reflects the way in which a statistical methodology is not integrated into how experiments are designed in the molecular and cellular preclinical life sciences, and that it's very much an afterthought. So this year we focused on doing a few things that we think are going to not only make the reporting standards that we have converged on as a group of journals more accessible to authors, but also perhaps reduce some of the pain points associated with implementing these reporting standards. So we're going to start publishing the checklist with every life science paper that's published in a Nature journal. And we hope that that will obviously not only increase accessibility of the information for readers, but it'll also increase author accountability for providing accurate information. We've made a number of changes to the way the checklist has been designed to make it more intuitive for authors to provide the information, and also to simplify the review and editorial vetting of the issues in the checklist. Finally, we are going to take a much harder approach towards transparency in data representation. For many years, we've encouraged authors to provide the full spectrum of data points when sample size is low, and to use approaches and data representation that encourages display of the full data distribution. And I think we're going to take a much more stringent approach in that direction, and possibly move toward a full mandate in that direction. So much of our work on reproducibility has actually focused on the life sciences, and that is partly because that's where some of the greatest challenges have been identified. But we've taken a different approach thus far in the physical sciences, and the approach in the physical sciences has been focused on developing discipline-specific standards in collaboration with experts. So we started that really in 2015 with the development of a checklist for solar cells, papers with photovoltaic cells. And then this year, we've developed another checklist for papers with lasers, and we've extended this approach of collaborating with experts in the field to develop discipline-specific standards to 3 life science approaches, techniques really, MRI, flow cytometry, and ChIP-seq. All these discipline-specific standards checklist will also be published alongside the published manuscript, and the templates for all these checklists, the discipline-specific checklists, as well as our life science reporting checklist are available CCBY at nature.com. We would be really happy for the community, including institutions and other journals, to reuse, adapt the checklist as they see fit. So I'm going to switch gears and talk to you about data and what we've done in relation to data, and I'm going to tell you a little bit about the Springer Nature data policy, and then also tell you about the data availability statement, data citation policy that we rolled out on the Nature journals last year. So we know that funders and institutions are introducing data policies, and we now have more than 40 research funders globally have policies or mandates that require data archiving as a condition of grants. Some of these are extremely prominent and large influential funders. Some funders and institutions also require data to be linked to publications. On the journal side, however, we know that there's a tremendous variance, even within a single publisher like Springer Nature, in terms of the existence of data policies. So we know that there's variation in terms of the existence and specifics of data policy. We know there's variation in discoverability and ease of interpretation for authors and readers, the extent to which individual journal data policies link to infrastructure like data repositories. And finally, we know that data policies for journals in general aren't necessarily aligned with funder policies. Ooh, okay. So the goal with developing a cohesive Springer Nature data policy was to standardize research data policies across the corpus of 2,000 plus journals, and to make our data policies accessible for authors, readers, and users, to increase awareness and visibility of data in the peer review process, and to support data sharing and reproducible research. So the policy consists of 4 categories that goes all the way from a minimal bar to, encourage data sharing and data citation, but not require it, all the way to the most stringent bar where there's a mandate on data sharing and evidence of data sharing is necessary, and peer review of large data sets is carried out as part of the peer review process. So there's a preprint on bioRxiv that summarizes the evolution of the data policy. Again, all the policy documents and templates are available CCBY if other stakeholders want to use them and adapt them. So what did we do at the Nature journal? So Nature has long had a policy of making data available and of exercising a mandate on data availability in a discipline-specific fashion. So last year, we rolled out a policy that mandated the inclusion of a data availability statement in all manuscripts reporting original research. So that's a policy that rolled out across all our life science, all our physical science manuscripts, across all 28 of our primary research journal manuscripts. So a data availability statement is essentially a statement about how data supporting the results reported in the article can be accessed. It reports the availability of the minimal data set to interpret, replicate, and extend findings, details of publicly available data sets that are analyzed or generated during the study, details of source data. There's also an expectation that restrictions on access, for example, due to privacy limitations, should be transparently noted in the availability statement. And finally, the policy also encourages data citation. So while the policy did not make a mandate on data availability, we took what we felt was a pragmatic approach that made an affirmative statement about the value of data sharing while being sensitive to the realities that many that many disciplines face with regard to data sharing. So as part of the policy, we introduced a number of, we provided a number of standard statements that authors could use to discuss, to make a statement about data that's publicly available in the supplementary information, sensitive data, third-party data available upon request, and theoretical papers. And we're hoping to do a much bigger and a more comprehensive analysis across our journals to see what we can learn about the prevalence of these statements and what that might tell us about disciplinary tendencies towards data sharing or how data is shared. But what I can tell you is the initial data is quite interesting in the sense that there are clear disciplinary preferences. For example, the majority of papers that we've looked at in neuroscience and physics, there is a tendency to not put data in the public domain. Data is typically available upon request from the authors. So we're hoping to learn more about disciplinary preferences and evolve our data policy with that deeper understanding. So finally, I just wanted to use this slide to illustrate the point that there has been a tremendous amount of awareness raising since we embarked on our reproducibility initiative. As Patricia mentioned last year, the NIH has released, yesterday, the NIH has released principles and guidelines on rigor and reproducibility. They've been endorsed by a number of journals. The top guidelines came out in 2015. A number of other journals and publishers have engaged with reproducibility efforts. A number of societies have released reproducibility recommendations. And then there are large-scale approaches undertaken to look at systemic sources of reproducibility in a disciplinary basis. And so I think there's been a lot of progress in terms of awareness raising, but I think the progress and effort needs to be sustained, and ultimately researchers, institutions, and funders have to engage with these efforts and make transparency and enabling reproducible research a kind of a fundamental value that undergirds the enterprise. So with my last slide, I'm going to switch gears and talk very, very in 2 seconds, literally, about authorship-related policies, and this is more of a research integrity issue than a reproducibility issue, and just share with this group that there are draft recommendations on authorship responsibilities and contributions that are available as a preprint on bioRxiv. The draft recommendations came out of a National Academies of Sciences workshop that was convened by the president of the academies and brought together journal editors from a very diverse set of disciplines, and we would love to get feedback from this community. So anyone who's interested in authorship, I'd highly encourage you to look at the preprint and provide feedback. And then finally, in my last slide, I just want to mention the people who did a lot of the work involved with some of the things I talked about. So Monia Baker and Dan Penny were behind the Nature Reproducibility Survey. Ian, who's the head of data publishing at Springer Nature, is really instrumental in driving our data policy. And then Meredith Allison Quinn and all the Nature Journal editors for their efforts on the life science checklist and for developing disciplinary standards.
Well, thank you very much for this clear overview of what journals can do and what your journals are in fact doing already. Are there any questions?
Boris.
Hi, yes, so Boris Barber from PubPeer. So one important facet of reproducibility that you didn't really touch on here is how journals and nature journals in particular respond when criticisms are made of a paper. And in a recent editorial, some very promising announcements were made. I quote, "We welcome and will be glad to help disseminate results that explore the validity of any publications, including our own, which is revolutionary. the editorials were devoid of any practical details of implementation.
Yeah.
And I would suggest that on the ground, the reality is still rather different from that ideal. And I'll make that concrete. I'm involved in trying to discuss or correct one paper in a Nature journal. The editors acknowledge a problem, and nothing has happened in 3.5 years. And I wonder if you felt that was acceptable.
So I can't obviously comment on any cases that are ongoing or on the specifics of any particular papers. But I do think that the process for responding to the published literature and for bringing the challenges, and not just the challenges to the published literature, but also when a piece of work has been replicated, for actually creating avenues to stitch all that together is still very much a work in progress. I will admit that it is a challenging process, but it is something that we are actively discussing and thinking about. And I do increasingly think that the traditional peer review process doesn't quite work for refutations and replications. And maybe what we need to do is really step back and think about an entirely different way to approach challenges to the published literature, and perhaps preprints will be a big part of how we deal with that.
Thank you. Last question, please.
Yes, thank you. I have a quick question about the data sharing. Your conversation with scientists and researchers. It's great to understand about guideline. But you mentioned about the third-party data. Do you also talk with multinational corporations or organizations? Because, for example, emerging field, medical device technology, they are very sensitive about sharing their data on human experiment and also engineering aspect. So from your perspective, how do you share the data from that coming from multinational corporations or private sectors?
Yeah, so we have not had conversations with multinationals, but we recognize that it is a challenge. And we also recognize that it's probably a challenge that we're going to encounter more frequently, especially as we launch journals that are moving into the applied space, like Nature Electronics. So I think these are the kinds of conversations that I think we are going to have internally and with external stakeholders.
Thank you.
Thank you. Thank you.